5, Astrotech. We're going to be presenting the vessel assignment project summary for the IND 6332 course. Just to start, we'll give a little introduction to the project members for Astrotech. I am the project manager, Sung Hong. The team members are Rajesh, Carrington, Kayla, Sinanth, and Venkat. We have a table of contents here that will show you what we'll be presenting today. To go over the executive summary to give you an overall view of what we've worked on for this specific project. The commercial objective for this is to build Texas Park and Wildlife has sent a request for information and proposal to have a small vessel built for the purpose of marine research. With comprehensive research of different vessels and different parameters, a candidate boat is proposed. Below, we have our major materials and parameters for our specific boat. So this will give you the scope of understanding of how our boat will be built. The size will be 36 feet. Hull materials would be aluminum. The number of engines is a twin diesel. Cabin coverage is a half cabin. Through some research that we found for operational costs, we've come to know that 19,000 to about 40,000 is about the cost to operate this boat. And with more specifics later on throughout our project, we'll narrow this down. These are the results for us. We used the constrained weighted factor method and summed up different constraints and specific criteria such as construction, hull material, engine configuration, and operational conditions. This table shows you a summation list for the different criteria for evaluating the boat and different configurations. From our results, you can see the boat configuration 15 has the largest sum, which gave us the configuration and confidence in our boat parameters. We took specific sizes and hull materials and engines and cabin design, looked at each parameter, construction, hull material, engine configuration, and operating conditions. Just as an example, our boat configuration, you can see that the first boat configuration is including 34 foot boat, fiberglass, single engine, and a half cabin. But 15 was our best parameters for this specific project. I will leave the rest of my team to discuss each of the specific parameters.
Oh, hi everyone. Going through construction, I'm going to talk about the few parameters that we kept in mind when going through construction. We discussed labor, material, durability, and cost. So, firstly, going through labor, based on our specifications, we estimate this project will take approximately 1,400 labor hours. To improve efficiency, a team of 2 or 4 people would be more ideal to reduce the build time and the duration of the boat building process. Secondly, we'll go through material selection. We were deciding between fiberglass and aluminum. Fiberglass is a common and cost-effective material widely used in boat construction. However, aluminum proved to be a better choice for our needs because it's lightweight, highly durable, and requires low maintenance. And it can also withstand tougher conditions than fiberglass. Lastly, our durability considerations. Aluminum naturally resists rust and marine deterioration, making it an excellent long-term investment. We are using heat-treated aluminum, which improves resistance to UV exposure, saltwater, and extreme temperatures. Additionally, we are incorporating anodized coating and sacrificial anodes, which help prevent corrosion in saltwater. This ensures that our boat remains structurally sound and minimizes future repair. Next slide.
Yeah, thank you. Good evening, everyone. Thanks for joining the call for the project presentation. And now we are going to discuss about the operation cost analysis of Richard's boats, and it comes with different aspects like the operation cost consists of fuel cost, maintenance, docking, insurance, and miscellaneous. We come to the fuel is the major operation cost, and maintenance it comes under repair and all those things. And docking depends upon the size of the boat, and insurance is based on the material which we are using, what the size and engine type, everything. Miscellaneous like what are the equipments we are using for safety purpose, permits, and all those things. And now we are discuss about why we select specific material or engine on both sides. And we have selected like aluminum is the best one for all the 24 probabilities because it is lighter in weight and more durable and good for the rough titles. And engine, we went for the twin engine because it's more powerful, and even though it is high fuel consumption, but for marine research we require more power, and for safety purpose twin engine is the best suitable one. And for boats we have three sizes of boats, like 34 feet, 36, 38. And for 34, 36, there's almost same operation cost, so we'll go for 36, which gives more space for research purpose. And half cabin is more sufficient and lighter, so we can for less operation cost. So can you move to next slide? Yeah, and here's the breakup for the annual estimation cost for the 36 aluminum twin cabin. And the fuel cost is a major thing you can see from the pie chart with 39%. And then it comes for the docking and storage fees, maintenance, and insurance and miscellaneous. Here's the breakup. You can see like fuel cost is almost $7,500, like maintenance 3,525, and docking and storage is around 4 to 10,000, insurance, miscellaneous, and total annual cost for is not exact cost, is estimation cost for maintaining operation cost for the boat is around roughly it's 20,000 to 40,000. Can you move to the next slide? Yeah, and is the breakup for the hourly how breakup, like fuel cost is around 6 to 90, maintenance is 30 to 50. And from the chart we can see the what is the breakup on all those things. And here is the key observation why we have selected these things. Fuel is the largest expense, and it makes 60% of the total cost. And maintenance cost increase with twin engine due to the high variable and service cost. But as we discussed, twin engine is better for safety and high speed. And docking and storage fees vary based on the location and marine facilities and all those things. Insurance is generally fixed; it's around be 5 to 10% of total expenses, like for total cost of the boat. And aluminum we already discussed is lighter in weight and high durability, good for research. And miscellaneous costs we already discussed, like safety gears, permits, and but it's more expensive. So these are the breakups for all for the operation cost. From here my friends will continue the remaining part. Thank you.
Yep, so next up is the speed section. So the constraints that we had for speed was that the boat would be able to sustain speeds of 20 to 22 knots and have a 15% reserve. So for this, just looking at each of our sections, we chose the 36 feet because at the 34 to 38 foot range, larger, thinner boats sustain higher speeds on average. Since all three of the size options were capable of reaching and sustaining the required speeds, we picked the middle option as it's a balance between speed and cost, since the 38 foot would be more expensive overall. For hull material, we chose aluminum. Fiberglass boats are generally heavier and require a little bit more horsepower to get moving than aluminum boats. The trade-off of this is that the fiberglass boats tend to offer a smoother ride with better control at the cost of speed, but the aluminum overall gives us more benefits for that. Cabin design, we went with the half cabin. The design isn't a huge impact on the speed of the boat, but just because half cabin works better for all the other materials, we stuck with it. Engines, twin diesel is what we went with. The twin engines allows for higher speed and maneuverability when compared to a single engine, and it gives us fault tolerance in case the engine failed or something like that to make sure that our people stay safer. Next.
Coming to operational conditions, our vessel is designed to make a challenging conditions, including limited workspace, temperature ranging from 30 degrees Fahrenheit to 110 degrees Fahrenheit, and 30 knots wind, and 5 foot sea. To ensure stability and efficiency, we choose 36 feet size for the boat and more space and for a better balance in rough water. The aluminum hull is strong and durable and requires minimal maintenance. We choose the twin diesel engine, which offers reliability with a backup engine safety for the improved maneuverability. The half cabin design provides storage space and protects the crew from harsh weather. In conclusion, this design ensures safety, durability, and efficiency, making it well suited for rough operational conditions. From here, my friend can continue.
Here are our references. This is the end of our presentation. Thank you for attending and listening. Thank you very much.
Thank you, guys. Thank you so much.
Thank you.
Thank you.
Thank you.